Good morning.
Good morning, sir.
Okay. So, in last lecture, we have started with the unit number 6, right? That is video representation formation. Okay. Now, in that, we have discussed about the what do you mean by video signal, right? Then basic working principle of video camera. Okay. How actually the video is been recorded by using the video camera. Then different parts, right, internal as well as external parts of the video camera, that parts also we have studied. Okay. How actually what you can say, the motion picture is captured, right, in video camera. Then different categories of video camera depending upon the usage and depending upon the applications. There are wide range of cameras. Some of the studios cameras there, some of the field cameras are there, night vision cameras are there, infrared cameras are there. So depending upon the usage and application, again we have lot more categories of camera. Okay, so that part also we have discussed. Then we have discussed about the scanning techniques, right? Horizontal scanning, vertical scanning. Then again we have two types of sampling: interlaced sampling technique. Okay. So that is based on the sampling, because irrespective of the signal, suppose you want to transmit that signal, you must go for a sampling, right? If you want to transmit that signal, you must go for a sampling. Okay. And you have to follow the even sampling theorem also. Okay. Now today the two three points of this unit number 6 is remaining. So we will cover that and we will finish this unit today. Okay. Now, what is digital video? Okay. What is digital video? So the digital video can be obtained either by sampling a raster scan or sampling the skin with a digital video camera. Okay. So there are two ways you can achieve or you can obtain a digital video. First is you can sampling a raster scan or sampling the scene, that means whatever you want to record, with a digital camera. Okay. And like an analog camera, digital video is also defined by a few parameters such as frame rate, the line number per frame, the number of samples per line, and the bit. Okay. As per analog video. Okay, what parameters we are using in analog video? So number of frames is common. Okay. Then what you can say, the frequency. Okay, frequency of the frames, that parameter we are considering analog thing. But in digital, which parameter we are using? Frame rate, line numbers per frame, number of samples per line, and the bits that been used. Okay, in analog there is no bit concept, it's an electrical signal. So normally we use the frequency, amplitude, right, that analog parameters. Okay. Then bit depth, that denotes the number of bits to be used, represent a pixel value. Okay. Again, in case of digital video, you can say a raw data rate of digital video can be computed as a product of this parameter, which has a unit of bits per second, that is a raw data bit. Okay. That means it's a what you can say, if you are using a digital camera, how many bits it can record or how many bits it can capture, right, per second. So it's a raw data bit, or you can say it, and its unit is a bits per second. That means how many bits it can able to capture per second. एका सेकंदात किती बिट कॅप्चर करू शकतो, that is a raw data bit. Okay. And normally you can say conventionally the luminance of each three color value is specified with 8 bits. That means 8 bit for a R, that means RGB basic primary colors we are using for a color video, right? So 8 bits for a each three colors, that means 8 bit for red, 8 bits for a green, 8 bits for a blue. Okay. So basically three colors and these primary RGB colors and 8 bit for each color. That means how many total? 24 bits, right? That 24 bit combines a color video. Okay. And if you are using a monochrome video, right, then it's only up to 8 bits. If you are using a monochrome video, that means a combination of this, then only there will be a 8 bits. Okay, because monochrome video don't have any color specifications. Okay, if you are going for the color specifications, then you have to go for RGB, that means 8 for R, 8 for blue, 8 for green, that is total 24 bits. Now in case of digital video, you can say uh, the chrominance components have a different sampling resolution, that means spatial and temporal, than that of a luminance. Okay, that means the chrominance components have a special or different sampling resolution as compared to the luminance. And in addition, another two important parameters are image aspect ratio and pixel aspect ratio. Okay, that is image aspect ratio and pixel aspect ratio. These two parameters are also important when you are considering the digital video. Okay, and the pixel aspect ratio indicates the ratio of width to the height of physical rectangular area used for the rendering a pixel. That means this pixel aspect ratio is a height to width ratio. हाईट टू विड्थ रेशो म्हणजे थोडक्यात अगदी सिंपल लँग्वेज मध्ये सांगायचं म्हणजे तुमची किती इंची स्क्रीन आहे, आपण म्हणतो का नाही 20ची, इट्स अ 12-inch टीव्ही, इट्स अ 24-inch टीव्ही. ऍक्च्युअली इट्स अ डायगोनल स्क्रीन. Okay, it's a diagonal what you can say length that we have measured. So that is nothing but a what you can say length length to depth width to height ratio, width to height ratio, right? So that's a pixel aspect ratio. म्हणजे it's a if suppose you can say it's a 12:4, that means the width is 12, height is 4. If suppose it has a 24:8 ratio, that means 24 is a width, right, and 8 is a height. 24th is a width and 8 is a height. So that's the pixel aspect ratio. This is also one of the important parameter in case of digital video. Now we will talk about some ITU RBT 601 standard. Okay, now what is this? So this ITU RBT 601 is a standard format used to represent a different analog TV signals, right? That may be a NTSC, that may be a PAL, that may be a SCAM. Okay, in India normally we are using NTSC, right? In India we are using a NTSC or PAL. I guess now some of the channel subscribers are using NTSC, some of the channel subscribers are using PAL also, but preferably I guess in India we are using NTSC system. Okay, now this ITU RBT 601 is a standard format used to represent a different analog signals. Okay, now what is this? So it specifies how to convert a one-dimensional raster scan into a digital video by sampling. म्हणजे जे तुम्ही व्हिडिओ कॅप्चर केलेला आहे तर त्याचं डिजिटल व्हिडिओ मध्ये कसं कन्व्हर्जन करायचं हे ते स्टँडर्ड सांगतं. कुठलं स्टँडर्ड? ITU RBT 601, right? So this is a standard used for any analog TV video signal. Okay, and see, nowadays everything is stereo. If you convert into analog, it's very simple to convert it into a digital. Okay, so this standard this standard specifies how to convert a 1D raster scan into a digital video by sampling. म्हणजे वन डायमेन्शनल तुम्ही जे रेकॉर्ड करता दॅट्स द वन डायमेन्शनल सिग्नल. ओके, त्या वन डायमेन्शनल सिग्नलचं 2D डिजिटल सिग्नल मध्ये बाय युझिंग सॅम्पलिंग कसं कन्व्हर्जन करायचं. सो दॅट इज द स्टँडर्ड अँड दॅट इज नोन ॲज ITU RBT 601. ओके, द सॅम्पलिंग रेट इज चोजन टू मीट टू कन्स्ट्रेंट्स. सॅम्पलिंग रेट कसा डिसाइड केला जातो? ज्या दोन कन्स्ट्रेंट वरनं. कुठले दोन कन्स्ट्रेंट? हॉरिझॉन्टल अँड व्हर्टिकल सॅम्पलिंग इंटरवल शुड मॅच. ओके, हॉरिझॉन्टल आणि व्हर्टिकल आपण जे काल पाहिलं हॉरिझॉन्टल स्कॅन आणि व्हर्टिकल स्कॅन, तर ते हॉरिझॉन्टल आणि व्हर्टिकल सॅम्पलिंग इंटरवल शुड मॅच. दिस इज द फर्स्ट थिंग. अँड सेकंड थिंग इज द सेम रेट should be used for NTSC and PAL SCM and it should be multiple of their respective line rates. Okay, that means for every system, that means doesn't matter you are using NTSC or PL or SCM, the same rate should be used for all these systems. And one more thing, it is not mandatory only the same rate, but the second condition is what? That rate should be multiple of their respective line rates. म्हणजे त्या NTSC, PAL किंवा SCM चा जो लाईन रेट आहे, तर तो सॅम्पलिंग रेट त्याचा मल्टिपल पाहिजे, राईट. तो सॅम्पलिंग रेट त्याचा मल्टिपल पाहिजे. दॅट मीन्स दॅट हॉरिझॉन्टल अँड व्हर्टिकल सॅम्पलिंग रेट, राईट, इट शुड बी अ मल्टिपल ऑफ दॅट रिस्पेक्टिव्ह सिस्टीम. दॅट मीन्स NTSC सिस्टीम साठीचा जो लाईन रेट आहे, तर तो सॅम्पलिंग रेट तुम्ही जो सिलेक्ट करणार आहात तो त्या लाईन रेटचा मल्टिपल पाहिजे. ही कंडिशन मॅच होणं गरजेचं आहे. देन अँड देन ओनली इट्स इझी to convert that 1D raster scan into a digital video. Okay, now we will talk about this ITU RBT 601 standard. So what is this? So it leads to a 11 megahertz for NTSC and 13 megahertz for PAL and SCAM. Okay, see this NTSC, PAL, SCM that you are going to discuss in your next semester subject, that is multimedia communication technique in detail. Okay, in this same you have just the introductory part. Okay, second, it needs a multiple of least communication multiples. That means it may be a 15,750 or 15,625. Then a number that satisfy both constraints is 33.5 megahertz. Okay, number that satisfy both constraints, it's a 33.5 megahertz. That means NTSC साठी पण किंवा PAL SCM पण तो मल्टिपल जो आहे, म्हणजे की दॅट मल्टिपल ऑफ इट्स लाईन रेट आणि सॅम्पलिंग फ्रिक्वेन्सी. सर सॅम्पलिंग फ्रिक्वेन्सी हा त्या लाईन रेटचा मल्टिपल पाहिजे. तर जो नंबर सॅम्पलिंग फ्रिक्वेन्सी त्याच्यावरनं जी निघते की जी त्या लाईन रेटची मल्टिपल पण आहे, तर दॅट फ्रिक्वेन्सी इज 13.5 megahertz. Okay, and with this sampling rate we will have 858 pixels per line for NTSC and 864 pixels for PAL and SCM. म्हणजे 13.5 megahertz या सॅम्पलिंग रेटनी 858 pixels for NTSC and 864 pixels for PAL and SCM system. Okay, now we will talk about the digital video formats. Okay, तर डिजिटल व्हिडिओचे काय फॉर्मॅट्स आहेत? फॉर एक्झाम्पल, all of you have studied the MP3 format, right? All of you have studied the video signal MP4 format. All of you are well aware of wave format. Wave is a totally analog signal, right? You have that analog signal. It is not a digital one. But when you consider MP4 format, then it's a composite signal. It's a video plus audio. When you consider the MP3 format, then it's a digital audio signal. Okay, so the rightmost actually when you talk about a digital video format, then whatever the rightmost column gives their raw data rates to indicate how much bandwidth it will take if they are transmitted without any compression. For an example, if you have a SD video with 4:2:0 color sampling, 4:2:0 म्हणजे काय की RGB, red is 4, G is 2 and B is 0 in that case. So this 4:2:0 color sampling and its raw data rate is 124 Mbps, 124 megabits per second, which is roughly the bandwidth limit that can be supported by the best Wi-Fi technology we have today. Okay, and this is the what you can say the maximum or the what you can say the bandwidth that we can, or the bandwidth threshold value that we can transmit with the color video signal. म्हणजे ही कलर व्हिडिओ मॅक्सिमम तुम्ही कितीचा पाठवू शकता? सो इट्स अ 124 Mbps color video you can send, or video signal you can send using current Wi-Fi technology. And if you talk about MPEG2 compression, then it's possible to reduce the bitrate to a 4 to 8 Mbps, which is equal to a 10 to 30x compression ratio. Okay, so it's 124 Mbps is like a large size. If you want to compress that, then you can use for MPEG2 compression technique. Okay, there are many compression techniques available. Okay, MPG2 compression is there. Then you have MPG3 compression technique. So that is all about. Now you can clearly see the digital video formats, right? So for 525 line and for 625 lines. Okay, so there are different parameters we have given here. Sampling frequency is 13.5 for both. Sampling frequency is same. Bandwidth is 5.5 megahertz. It is also same. Number of samples per line, it's a 858 sample per line for uh, first technique, that is NTSC. Then for another it's a 864 number of samples per line. Number of samples for active line, both are again same. Bits per sample, 8 bits per second, right? So these are the 8 bits per second. Bit rate is 108 mbps. So for both it's a same, and it's for the luma channels, that means monochrome. And for chroma, that means color difference channel. So sampling frequency is 6.75 megahertz. Bandwidth is 2.2 megahertz for both techniques. Number of samples per line is only difference. That is a in first case it's a 429, and in second case it's a 432 sample per line. Okay, bits per second is also same, 8 bits per second. Bit rate is now increased for the chroma, because see, in chroma, that means the color difference channel, you have the three components or three color components. Okay, for chroma you have only one. So it's easy to transmit. So bit rate is 54 mbps and total bit rate is 216 mbps. How it will come to 16? So three composite signal and one is for the audio one. So it's a total bit rate is 3 times the basic bit rate for one color and plus audio. That is the that is for the chroma or color signal. Okay. Now next thing is a composite video signal. Now what we are talking about, the only video signal. But when you combine the audio and video in a one signal, you might have learned in your analog communication, right? You have that video signal, right? So video signal is amplitude modulated and the audio signal is frequency modulated. Then there are some vestigial band system, right? VSB मॉड्युलेशन टेक्निक व्हिडिओ ट्रान्समिशन साठी वापरतात. शिकलात का नाही अनालॉग कम्युनिकेशन मध्ये? तर ते ऑडिओ आणि व्हिडिओ सिग्नल इज नथिंग बट द कॉम्पोजिट सिग्नल. कॉम्पोजिट सिग्नल मीन्स व्हॉट? इट्स अ मिक्सचर of a audio signal and video signal. Okay, now how it will looks like actually? So this is a throughout diagram of the composite video signal. So you have a dark level, then you have a blanking level or two horizontal synchronous pulses, then you have a picture detail signal. Okay, within one line duration you have a picture, then active line period. Okay, then you have all these have some peculiar timings also, right? All these have some peculiar timings also. For example, that one line duration is for 64 microsecond, and another active line period is for 52 microseconds. Okay, and each have some certain predefined amplitude, that means DC level. DC level is also fixed one, and that time duration is also fixed one. Okay, so you can able to see how what is the DC level. So your horizontal pulse is normally occur at 75 volt, 75 volt maximum, 200 volt. Then what you can say, your one line duration pulse is occurring at 75 volt. Okay, and rest your signals, that means your horizontal blanking level signal and picture details are available at very low voltage. That means hardly it's a 50 volt, right? And for active line period it's a still very low, it's hardly at 25 30 volt. Okay, but the pulses, horizontal synchronous pulses and duration pulses, that are at very high voltage, that means 75 volt and above. Okay, so this is the total composite video signal. That means it has some picture details, it has some active line details, right? And these horizontal pulses, why we are using these horizontal pulses? To synchronous, right? For the synchronization pulses. म्हणजे जेव्हा एखादा व्हिडिओ स्टार्ट होतो, ओके. सो you have to synchronize that video. नाहीतर असं नाही की with any rate you can pass that frames. No, there should be a synchronous की किती वेळानंतर दुसरी फ्रेम आली पाहिजे, किती वेळानंतर नेक्स्ट व्हिडिओ फ्रेम आली पाहिजे. So all we have to synchronize everything. Then and then only we can able to see the smooth video. Otherwise there will be what you can say a lot of confusion, lot of overlapping, and lot of problematic situation will be there. So synchronization is very, very essential. Okay. Now, composite video signal, we will talk about some features of this component video signal. Now, it varies between certain limit, that is 10 to 12.5%. Black level is 72%. Blanking level, that means synchronous percent, is 75% of the total DC level. Then you have a pedestal height, that means distance between the pedestal level and the DC level indicates the average brightness. Then picture information, right, it's a 10% to 72%. Then pedestal level, pedestal means it's a difference between the black level and the blanking level, that tends to merge. Okay. And this is about the what you can say video signal. ओके. कॉम्पोजिट व्हिडिओ सिग्नल, त्यामुळे म्हणजे ह्या ज्या लेवल्स दिलेल्या आहेत, सो ऍक्च्युली इट्स अ व्होल्टेज टू व्होल्टेज अँड इट्स अ मॅक्सिमम पर्सेंटेज. दॅट मीन्स मॅक्सिमम पर्सेंटेज ऑफ द डीसी व्हॅल्यू, दॅट्स द व्होल्टेज. डीसी म्हणजे काय शेवट, इट्स अ काइंड ऑफ व्होल्टेज दॅट यू कॅन ऍड इन टू अ व्हिडिओ सिग्नल. त्यामुळे या प्रत्येकाच्या या प्री डिफाईन्ड लेवल्स असतात आणि त्या लेवल्स तुम्हाला मेंटेन ठेवाव्या लागतात थ्रू आउट युअर व्हिडिओ सिग्नल. Throughout your video signal. That means after this cycle, again it begins with this first one. Then again there is a darker level. Then again is a blanking level. Then again is a picture details. Again active period details. Okay, here ends the line. Again after some time you have that repetition of this cycle, right? And this complete one cycle represent a single frame. ही complete एक cycle म्हणजे एक फ्रेम रिप्रेझेंट करते. अशा प्रत्येक फ्रेम तुम्हाला सिंक्रोनाइज करून घ्याव्या लागतात. देन अँड देन ओनली यू कॅन हॅव अ स्मूथ व्हिडिओ. बरोबर आहे. आणि त्याच्या जेवढ्या काही पर्सेंटेज ऑफ मॅक्सिमम डीसी व्हॅल्यूज आहेत किंवा हे जे डीसी पेडेस्टियल व्हॅल्यूज त्याला म्हणतात इन टेक्निकल टर्म्स ऑफ व्हिडिओ प्रोसेसिंग, इट इज नोन एज पेडेस्टियल हाईट. So you have to maintain this pedestal height. That means that you have to insert that DC value or DC threshold to maintain that particular height or the particular voltage, so that there will be a proper synchronization. There will be a proper synchronization. Okay. So this is about the composite video signal. So in this unit number 6, you have this 4 to 5 important points, right? That is the first one is a what do you mean by video signal, a definition of video signal. Then camera, working of a video camera. Then interlaced scanning, different scanning techniques, horizontal scanning, vertical scanning, that is all. Then internal and external parts of the video camera. Then you have a digital video, then different digital video formats. Okay. ITU standard. Okay, ITU 601 standard is there in for your syllabus. Then composite video signal and its signal representation. That means the what you can say, the point that we have studied recently. Okay, that's a structure or what you can say representation of composite video signal. Okay, so these are the main important points in your syllabus or in unit number 6. Okay. So we have finished with this unit number 6. In probably today's lecture, we will start with the unit number 7. Okay. And we will try to finish it in 2 lectures. Okay. So tomorrow I have 2 lectures. Okay. 9:30 to 11:30. So probably in that period, I will try to finish the unit number 7. So we will stop here. If you have any doubt, you can ask me right now related to this unit. See, last units are totally dealing with the video processing, and I know these are the much tedious to understand. Even image processing is quite simple. You can realize everything there. here you have to understand some multimedia. That means that video systems actually. So if you have any query, you can ask me right now, or we will stop here. Okay. Next lecture, we will start with the unit number 7. That is the last unit of your syllabus, and thereafter, uh, again, we will start with the revision of the same. Okay. From again first unit, we will start with the revision. And still, many of you are remaining absent. So it's my humble request. Okay. So for revision session, 100% attendance is expected from you. So don't miss the classes. It's for your betterment. Otherwise, you have to face the consequences. Okay, we will stop here.